Welcome. If you're doing any kind of digital investigation in the cloud, you know how tricky it can be. So today, we're going to create an essential map for navigating that world. We're going to focus on the single most important concept you have to master, the separation of responsibility. Honestly, understanding this is everything. It's the key to knowing where the evidence lives and who can even give you access to it in the first place.
Okay, so let's dive right in by looking at just how much things have changed. In the old world of traditional forensics, it was all about the physical. You had full control. You could literally walk into a data center, unplug a server, and carry the hardware out. But in the cloud? Yeah, that world is ancient history. Now it's all about logical access, you have very limited control, and you're formally requesting logs from provider. The entire rulebook has been thrown out and rewritten from scratch.
So here's our game plan. We'll kick things off with the core challenges. Then we'll introduce the map that's going to help us navigate. We'll break down exactly who owns what, look at a real-world example with AWS, build out a practical playbook from that knowledge, and then we'll take a quick peek into the future.
So what is it that makes cloud forensics so different and, let's be honest, so incredibly challenging? Well, it kind of feels like you're trying to investigate a crime scene where the room itself, all the furniture, and even the laws of physics are owned and controlled by someone else.
At its core, the definition seems simple enough, right? It's just applying digital forensics to the cloud. But that very simple definition hides a whole universe of complexity. It's really a subdiscipline of network forensics because you're almost always interacting with evidence over a network, not with a physical hard drive you can actually hold in your hand.
And the hurdles you're up against? They're significant. First off, your access is seriously limited. You can't just go grab the hardware. Then there's the evidence itself. It can be ephemeral, meaning some logs might only exist for 90 days before they just evaporate. Your data isn't in one neat little box. It's scattered across dozens of services, which can be a total nightmare when you're trying to piece together a timeline. And to top it all off, that data could be stored in multiple countries, throwing you into a legal maze of international laws.
But there is a foundational concept that cuts right through all this fog. If you remember one single thing from this explainer, please make it this: the shared responsibility model. This is not just some boring compliance term. For a forensic practitioner, this is your primary navigation tool. This is your map.
And what is it? Put simply, it's a formal agreement. It draws a very clear line in the sand, defining what the cloud service provider, the CSP, is responsible for, and what you, the customer, are responsible for. This model tells you where you can look for evidence, what evidence you can get, and who you need to ask for it. It is the map.
Now, here's the crucial part. That line of responsibility we just talked about, it's not static. It actually moves, depending on the type of cloud service you're using, whether that's infrastructure, platform, or software as a service. And what's so cool about this table is how it shows you that shift. With infrastructure as a service, or IaaS, you're responsible for a whole lot: the operating system, the apps, your data. But as you move down to platform as a service, or PaaS, the provider starts taking on more, like the OS and the runtime. And by the time you get to software as a service, SaaS, think about something like Google Docs, you're really only responsible for your data and who has access to it. Your investigative service area shrinks a lot. Okay, theory is great, but let's make this concrete. Let's take a look at how the world's biggest cloud provider, Amazon Web Services, actually puts this model into action. This isn't just theory. This has very real-world consequences for any investigator.
And this illustrates that divide perfectly. AWS is responsible for security of the cloud. What does that mean? The physical data centers, the servers, the networking, the whole global infrastructure. But you, the customer, are responsible for security in the cloud. That's your data, your applications, your user access policies, how you set up your firewalls. So if a misconfigured firewall is the root cause of an incident, that's on you, and the evidence is going to be in your logs.
You see, understanding this model directly shapes your forensic workflow. It fundamentally changes how you acquire evidence. You can't just pull the drive anymore. You need a whole new playbook.
So, this is your new process in action. Instead of physically seizing a server, you follow this precise 6-step logical acquisition for, say, an Amazon EC2 instance. You isolate the machine using a virtual firewall. Then you take what's called an EBS volume snapshot. Just think of it as a perfect digital photograph of the hard drive at that exact moment. Then you carefully attach that copy to a clean forensic workstation for analysis. Every single step here is a logical action done through an API, because that physical access just isn't an option.
And inside that entire process, this one command, this is arguably the most important one.
That little optional O row flag, it mounts the evidence volume in read-only mode. This is your digital equivalent of putting the original hard drive in a sealed evidence bag. It is the technical guarantee that you are not altering the evidence, preserving its integrity for your analysis and potentially for court.
This model also completely dictates the tools you use. You're not using hardware write blockers anymore. You're using tools like the AWS command line interface to sift through API call logs looking for unauthorized access. Or you might use a query service like Amazon Athena to hunt through massive server access logs to find out exactly who deleted a critical file and when they did it. These tools are all designed to analyze the data that you're responsible for.
All right, let's wrap this up by looking at where this is all going, because the cloud is only getting more abstract. If you think investigating infrastructure as a service is a challenge, the next evolution takes things even further.
We're moving into the era of function as a service, or FaaS, which you probably know as serverless computing. With services like AWS Lambda, you don't even manage a virtual machine anymore. You just provide the code, and the cloud provider runs it for you. The whole concept of an operating system you can analyze is completely abstracted away, pushing that line of responsibility even further toward the provider.
And that leaves us with a final and pretty provocative question. As the infrastructure keeps vanishing into abstraction, what does an investigator even seize? We've already moved from physical servers to logical volumes. Soon, we might only have ephemeral execution logs. Our entire concept of what digital evidence is and how we acquire it has to keep evolving right alongside the cloud itself.